Today we're talking about how do we round decimal numbers or decimals. So we're going to look at yesterday's example, or the last decimal we looked at yesterday, 3/8 as a fraction. We turned it into the decimal 0.375 by doing division. So I want to work with that number, 0.375. And just as a refresher, remember our place values here. Right after the decimal is the tenths place, 2 spaces over is the hundredths place, and 3 spaces over is the thousandths. The next one would be the 10,000ths, then 100,000ths, and on and on and on. So I want to work with this number and I want to round it. What rounding is we're condensing, or we're making the decimal number smaller, okay? So I'm going to say that I want to round to the hundredths place, which means we're going to get rid of everything to the right. We'll go over that in just a second. But I want to round this answer, or round this number, to the hundredths place. So there's some steps we need to follow whenever we're rounding a decimal number. The first step is we need to find the right place value. So in this case, we're rounding to the hundredths place, so I need to find the hundredths place. Well, there it is. I have it labeled here. It's 2 spaces after the decimal. All right, so I got a 7 in my hundredths place. Cool, we found the right place value. The next step is I got to check the neighbor to the right of the place value that I'm looking at. So I'm looking at the hundredths place, I got to check the neighbor to the right. And what we're going to do using that neighbor to the right is, if the neighbor to the right is 5 or more, we're going to increase the place value that we're rounding to by 1. So if the neighbor to the right is 5 or more, we're going to increase our hundredths place by 1. If, however, the neighbor to the right is 4 or less, we're just going to leave that hundredths place number alone. So if we look here, here's our hundredths place again, we got a 7. We're going to look at the neighbor to the right. It's 5 or more. It is 5. So we're going to add 1 to the 7 there. So I'm going to go ahead and do that now. And we're going to make this 8. All right, 8. Okay, so we added 1 there. Great. Now, the next step is drop all the numbers to the right of our place value. Drop all the numbers to the right of the place value we are rounding our number to. So again, we're rounding our number to the hundredths place, and we manipulated it by checking the neighbor to the right. Now we're gonna drop all the numbers to the right. So I'm gonna get rid of that 5, and I'm gonna rewrite this so it's a little cleaner. 0.38, that is the answer rounded to the hundredths place, which basically means that my decimal stops at the hundredths place value. All right, so how does rounding help us understand a decimal number's meaning? Why are we doing this? How does this help us at all? Well, we can use our common decimal numbers that we've talked about before. We also call these benchmark decimals, because these are the ones that we're going to see on a regular basis. 0.25, 0.33, 0.50, 0.66, that's supposed to be a 6, 0.66, and 0.75. These are our benchmark decimals. And I want to figure out the value. I'm having trouble really conceptualizing what the value of 0.46 is. Well, I can round this. I can round this number to the nearest tenths place and figure out where it's close to. So I'm going to follow my rules again. I'm rounding to the tenths place, so I find the tenths place, which is right here. That's where the 4 is. Then I'm going to check the neighbor to the right. It's 5 or more. It's a 6. So I'm going to increase this by 1. So that's going to change into a 5. And then I drop everything to the right. Okay? Now, I can always, if there's nothing else after a number in a decimal, I can always just add zeros. I could keep adding zeros forever, but I'm going to stop right there. And so what I find is that 0.50, well, hey, there it is. So my original number of 0.46 is pretty close to 0.50. That's about an approximate value for 0.46. So that's one way we can use rounding numbers to help us understand the value of a decimal. How do we work with decimal numbers that never end? So there are some that just go on and on forever. Let's look at some examples of those. So one of the most common ones that we'll see is 1/3, the fraction 1/3. Well, that's actually the decimal 0.3 repeating, and it just goes 3, 3, 3, 3, 3 on forever and ever and ever. And we call this a repeating decimal. But rather than write these 3's forever, because we're going to simplify or condense this to writing it as a line over the 3. So what we're looking for is we're looking for a pattern that occurs after the decimal point. And so the pattern here was that 3's just repeated forever. So I write a line over the 3's, and then that tells me, this line tells me that these 3's go on forever, but then I don't actually have to write them forever. So here's another example. The fraction 3/11 gives us the decimal 0.27272727. Well, I can see there's a pattern forming here, 2727, it just repeats itself. Well, rather than writing 27 for forever, because I don't have time for that, I'm going to write it as 0.27 and just write the line over the 27, because that is the pattern that is repeating forever. There's also a different type of decimal number that goes forever, but it doesn't have a pattern. And these are called irrational numbers. So here's kind of an example, 0.846376, you know, there's no rhyme or reason, there's no pattern to this. I can't condense it down. I can't just write it as an abbreviated form with a line over it. There's a famous irrational number called pi, and we use this symbol to represent it. And so pi is an irrational number. It's 3.1415926, and it just goes on and on forever. And there's no pattern to it. So rather than writing out the digits forever, we usually abbreviate this number as 3.14. It's not the exact value of pi, but it's pretty close, and it's something that we can actually use in class rather than spending the rest of our lives writing all the digits of pi.